Semiconductor Packaging. John D. Thomas, Alex Ruth. Book 5, Section 2, Chapter 1, Topic 1.
Semiconductor packaging is a critical process in the production of integrated circuits, ICs, where the semiconductor die, interconnects, power components, and thermal management elements are assembled onto a carrier substrate. This process ensures that the delicate semiconductor components are protected, interconnected, and provided with the necessary thermal dissipation mechanisms to ensure optimal performance and reliability. In this overview, we will delve into the various stages of semiconductor packaging assembly, from die attachment to final inspection, highlighting the importance of each step in ensuring the quality and functionality of the packaged ICs.
Die attachment and interconnect formation.
The semiconductor packaging process begins with die attachment, where the semiconductor die, typically made of silicon, is mounted onto the carrier substrate using adhesive or solder. Precision and accuracy are crucial during this stage to ensure proper alignment and contact between the die and the substrate. Once the die is attached, interconnects are formed to establish electrical connections between the die and the external leads or contacts on the package. This step often involves wire bonding or flip-chip bonding techniques, depending on the packaging technology and design requirements.
Integration of power and thermal management elements. In addition to electrical connections, semiconductor packages often incorporate power and thermal management elements to ensure efficient operation and reliability. These elements may include power distribution networks, heat sinks, thermal pads, and other components designed to manage power dissipation and regulate operating temperatures. Integration of these elements is essential to prevent overheating, improve performance, and extend the lifespan of the packaged ICs. Encapsulation and sealing. Once the die, interconnects, and additional components are in place, the semiconductor package is encapsulated or sealed using an appropriate material, such as epoxy resin or molding compound. Encapsulation protects the sensitive semiconductor components from environmental factors, such as moisture, dust, and mechanical stress, while also providing mechanical support and structural integrity to the package. The encapsulation process must be carefully controlled to ensure uniform coverage and minimal voids or defects within the package. Initial testing. After encapsulation, the packaged ICs undergo initial testing to identify any defects or irregularities that may have occurred during the assembly process. This testing typically involves sending stimuli to specific structures within the semiconductor die, known as target-specific transistors, to assess their electrical characteristics and functionality. Any deviations from the expected response may indicate potential defects or issues that require further investigation. Functional testing. Following the initial testing, the packaged ICs undergo functional testing to verify their performance and functionality according to the product design specifications. This testing involves subjecting the devices to a series of electrical stimuli and operating conditions to assess their ability to perform the intended functions accurately and reliably. Functional testing helps ensure that the packaged ICs meet the quality standards and requirements set by the manufacturer and the end-user applications. Finish and inspection. After successfully passing the functional tests, the packaged ICs undergo finishing processes, which may include final inspection, laser marking, and labeling. During final inspection, the packages are thoroughly examined for any defects, such as cracks, voids, or irregularities in the encapsulation or solder joints. Laser marking is often used to apply serial numbers, date codes, or other identifying information to the packages for traceability and quality control purposes. Once inspected and marked, the packages are packed and prepared for shipment to the customer. Packaging and shipment. The final stage of the semiconductor packaging process involves packaging the inspected and labeled ICs into trays, tubes, or reels, depending on the customer's requirements and the intended application. Proper packaging is essential to protect the packaged ICs during transportation and storage, minimizing the risk of damage or contamination. Once packaged, the ICs are shipped to the customer for integration into electronic devices or further assembly into end products. Conclusion. In conclusion, the semiconductor packaging assembly is a complex and meticulous process that involves multiple stages, from die attachment to final inspection and packaging. Each step is essential for ensuring the quality, functionality, and reliability of the packaged ICs, ultimately contributing to the performance and longevity of electronic devices in various applications. By adhering to stringent quality control measures and employing advanced assembly techniques,
semiconductor manufacturers can produce high-quality packaged ICs that meet the demands of the modern electronics industry. Thanks for watching.
Please like, share, and subscribe.